Hi class, I am hoping to be able to put together this video so that you can use it for reviewing for the test, Chapter 7. So it's our Chapter 7 review. And what I'd like to do is give you an opportunity to see how we're doing some of these problems and then try them yourself. So let me start first with section 7.1. And section 7.1 is titled Completing the Square. And in completing the square, there's a couple things that you need to pay mind to. Now, as we're going through, sometimes I'll be giving you information that may not be of interest in you because you already know it well, in which case I would gladly suggest that you move ahead, go fast forward on this, but I just want to make sure that I cover this for everyone else. Before completing the square, I just want to remind you that the concept of completing the square comes from quadratics that are similar to this, where you have something like x squared plus 6x plus 9. If you factor this, you will get an x plus 3 and an x plus 3, which is x plus 3 quantity squared. So again, this is very similar to a number like 49 or 16 or 25 that have perfect squares. What we recognize to complete the square, say, for instance, I'm asking you to complete the square x squared minus 14x plus some number. The number that goes in that blank spot is the number that creates completes the square and makes it a perfect square. To do this, what happens is we take the middle term, the 14, and we divide it by 2, in this case to get -7, and then we'll square it. And this becomes the number that goes over here. Again, if you wanted to try to factor it, you're going to get x minus 7 times x minus 7, or x minus 7 squared. So we're going to use this trick to be able to produce a method for solving equations. And so there are two types of equations that you're going to need to know how to solve. One is where the coefficient of the quadratic is 1. That's the easy one. And the one where the coefficient of the quadratic is some number other than 1. So what I'm going to do is I'm going to do the worst one first, the more challenging one first. So let me go to the next page about completing the square and the idea of the concept that we need to, the idea of cutting the middle term coefficient in half and squaring it to get the next term. And here's the problem that I'll give you is this is on page 310. It's question number 22. And it is 3n squared plus 12n plus 1 equals 0. So this is a problem that can not be factored. And again, this is the most difficult of the completing the square problems. The reason it's the most difficult is because we need to get the term, the n squared term, to have a coefficient of 1. And the only way to do that, or the simplest way to do that, is to divide every number, every term by 3. Now we have n squared plus 4n plus 1/3 equals 0. Now that I've removed the larger coefficient of the quadratic term, what I can do is now go through the process of completing the square. To do so, the first step is to get the constant term and move it to the other side. And so I'm going to subtract the 1/3, and I end up with n squared plus 4n, and I'm going to say plus something, is going to be equal to -1/3 plus something. Whatever I add to the left, I'm going to add to the right. What I showed you in the previous example is that I need to take 1/2 of the middle term 4 and then square it. That's going to be 2, which squared is going to be 4. I need to add it to the other side. If you're clever enough to think about writing the 4 with a common denominator of 3, you would write it as 12/3. And that saves you a little bit of time and maybe makes things a little bit easier for you. So now what happens is I can collapse the left-hand side to become n plus 2 squared. You can just factor that if it makes it easier for you. And is going to be equal to 12/3 and a minus 1/3 gives me 11/3. So almost there. So by completing the square, we produce a situation where we can take the square root of both sides and not make a big mess. So we take the square root of both sides, and I get n plus 2 equals, I'm going to divide this up, plus or minus square root of 11 over the square root of 3. One more step is to get the 2 to the other side and simplify the radical on the right. We can simplify the radical on the right by multiplying the top and the bottom by the square root of 3, if you remember that from a previous chapter. So now I get n is equal to minus 2 plus or minus the square root of 33 over 3. Now, take a moment and look at that. I kind of skipped some steps and hurried things along. One of the steps that kind of hurried things along was just putting the 4 in terms of thirds. The other thing to watch out for is to simplify. That's a kind of a 1-point thing on the test. And so again, this represents the most challenging type of question that you're going to get. One that you could practice right now is this one. So you just watched me do this. Once I write this problem down, why don't you pause for a moment and see if you get this on your own. So here's your practice question. It's going to be I'm sorry about that, 2x squared minus 8x minus 3 equals 0. So this is the question that I want you to practice. Let me see if I can highlight that for you. So what I want you to do right now is go ahead and pause, and once you feel you have the answer, what I'll do is I'll write the correct answer, and hopefully you'll get it right. Okay, hope that went all right for you. The final answer is going to be 2 plus or minus. You go ahead and I'll write that down for you. Is 2 plus or minus the square root of 22 over 2. A few things that may have caused you trouble is you may not have simplified the square root of 11 over the square root of 2. And also just remember that to be able to get the common denominator. So I'll give you some more practice on those at the end. I have some suggested practice, but let's go on now to the more easier version of this, and we'll do one of those. Should not take us long. We use this as a tool to solve equations. So an example of a simpler version of a completing the square problem would be, this is number 13 in the book on page 310, and it's x squared minus 2x minus 5 equals 0. Again, the reason this one is not so difficult is that we have a coefficient of 1 in the quadratic term. So we don't have to divide anything out. So we just need to go ahead and prepare to complete the square by putting the constant on the other side. When I add 5 to both sides, I get a 5 plus some number I'm going to be adding to both sides. So again, the technique is to take 1/2 of the middle term coefficient, which is -2. 1/2 is -1. And when I square -1, I get 1. Again, I need to add that to the other side. Now I can collapse this trinomial into a perfect square of x minus 1 squared equals 6. Square rooting both sides, I get x minus 1 equals, don't forget the plus or minus square root of 6. Now add 1, and our final answer becomes, or answers becomes 1 plus root 6 and 1 minus root 6. 2 answers. So if you were able to do the first one, then you're likely going to find this one to be a cakewalk, but let's go ahead and do it anyway, just to build some confidence. Here is your practice problem. And so try this one on your own. X squared minus 4x plus 2 equals 0. And again, I would like you to pause and write this down and go ahead and see if you can get the correct answer. Once you find the correct answer, go ahead and turn this video back on and let's go ahead and see if you got the right one. So I'm pausing right now. Okay, if things went well for you, you should have gotten the answer 2 plus or minus the square root of 2. And if that happened, you're in a good place. That's 2 answers again. Okay, let's move on to the next section. The next section we moved on. The next section is 7.2, and it is the quadratic formula. And the quadratic formula is x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And again, those letters come from standard form of a quadratic equation. So an example would be 5y squared minus 6y plus 3 equals 0. So to solve this problem using the quadratic formula, we recognize that this number before the y squared is our a value, the number before the y is our b, and the number before the 3 is c. If it doesn't, if the equation is given to you in a different order, you should rewrite it in standard form order with the x squared number first, followed by the x, and then followed by what we call the constant term, no x's at all. So let's go ahead and plug in these values. Negative b in this case is going to be a positive 6 plus or minus the square root of negative 6 squared. And I'm going to put that in parentheses to make sure that that becomes positive. It always should become a positive number, that squared value. Minus 4, a is 5, and c is 3. It's worth noting right now that this term inside is the first term will be positive and the second one will be negative. There's only a negative. You see how there's a negative 4 here, no other negatives, just to make sure. A lot of you guys are not so careful with your negative signs, and you don't want to make any mistakes and lose easy points on that. So let's go to, and of course we have over 2a, which in this case is going to be 2 times 5 or 10. So simplifying, you get 6 plus or minus the square root of 36 minus, now 4 times 5 is 20, times 3 should be 60. Again, over 10. And fast running out of room here, but 36 minus 60 should give me something like 24. And I would love to just go ahead and move this over, but I'm not exactly sure how. But let me write it over here. It's going to be 6 plus or minus the square root of 24 over 10. Now this can be simplified because there's a perfect square in the 24, which is the 4. So if I take out the 4, I'm going to get 6 plus or minus. The 4 comes out as a 2, and we still have a root 6 inside and a 10. Now, some of you need to be very careful here because there's 2 terms on the top. So if I'm going to reduce this, I can reduce everything by 2, but I need to make sure I reduce the 6 and the 2 and the 10 by 2. Final answer, again, I'm running out of space, but I'll go ahead and write my final answer way up here. I divide everything by 2, I get 3 plus or minus root 6 over 5, and that is the answer. So what the quadratic formula allows us to do is to avoid completing the square. Still, we end up getting those irrational answers. But let's go ahead and have you guys try to do one on your own. See how that pans out. So the one I have for you to do is this one. So your practice is going to be 5x squared plus 3x minus 2 equals 0. So here's your practice question right here. And I'm going to ask you to, first of all, once you pause, take a moment, make sure that you've memorized the quadratic formula. Some people were putting a plus sign inside the radical. You don't want to be that person. So memorize it, put this on pause, do the problem that I just did, and when you come off of the pause, I will have the answer for you. Okay, hopefully you're okay with that. This one was rather kind. It didn't end up with a radical answer, but the 2 values that you should have gotten are 2/5 and -1. So if that happened to you, then you're in pretty good shape. Otherwise, this is going to be something that you're going to need to practice. And again, this is section 7.2 on inside the textbook. Beginning to section 7.2, which is where we were introduced to the quadratic formula. Make sure you memorize this -b plus or minus the square root of b squared minus 4ac over 2a before you walk in. Some of you were putting plus signs in there instead of the minus signs, so let's just make sure we know this before you. Section 7.3 is titled The Discriminant. The discriminant is the value inside the quadratic formula that's underneath the radical. And because it's in the radical, it gives us a sense for the types of answers that we might get. So if this is my formula for the quadratic, this is the quadratic formula, if I can extract this little part that goes inside the radical and pull it out and call it the discriminant, we'll know by capital D, this number tells us what types of answers or roots we should expect in a quadratic. So because it's a radical, if the number inside becomes negative, that tells us that if D is negative, that we must end up with an imaginary root, because a radical of a negative number gives us an imaginary root. So I'm only asking on the test that you know that a discriminant that gives a negative value is going to give us a imaginary root. And the word root, again, means the same thing as answer. If D is positive, that means, and that's usually the situation we deal with. If there's a positive value inside the radical, then we'd expect there to be a real value answer. Either it's going to be irrational or a rational number, but I'm only going to ask that you know that it's a real. The only other option is that if it's neither negative nor positive, that means that D would have to equal 0, in which case we get two answers that are the same number, which we call a double root. So how do we use the discriminant? The questions for the discriminant are actually a lot easier than a lot of you guys make it. Move on to the test. The discriminant, a lot of you make more work out of this than you should, but it says b squared minus 4ac. If it's negative, that means that your answers will be imaginary when you work them out. If the b squared minus 4ac is positive, that means that your answers are going to be real answers. They could also be irrational or irrational or rational. And if it's 0, we get a double root, as you guys saw. Page. I'll give you an example. If they ask me, what is the nature of the roots? Here's the question. What is the nature of the roots of, here's the equation, I'm going to go x squared plus 6x minus 2 equals 0. So the nature of the roots, basically the nature is going to be either imaginary, real, or double. Roots is just another name for answers. So that's it. So let's go ahead and determine what it's going to be. Well, let's take b squared minus 4 times a times c. B squared is going to be 6 squared minus 4 times 1 is a, and c is negative 2. 36 plus 8. Y plus, people, minus sign here, minus sign here. Two minus signs make a positive. So we have 44. Because this number is positive, sorry, that was my wife calling me. Anyway, because this number is positive, we know that the answers will be real. If it were negative, we would say imaginary. If it was a 0, we would say double. So this is it. It's just that, and it's almost problematic because it's so simple. But the discriminant, which allows us to determine the nature of the roots, is just this formula here. All right, nothing more. We don't put the radical over it or anything else. Though I recognize that you're seeing this from the quadratic formula perspective. But this is the formula that we need to know to find the nature of the roots. So don't make it a bigger deal than it really is. Okay. Let's move on to section 7.5, graphing. Quiz. So the nature of the roots, just to translate, means that, are they imaginary, real, or double? Those are the three words that I'm going to be dealing with. The book I know goes to imaginary conjugates, real conjugates, things like that. I'm just going to ask you for that one word answer. Root is another word for answer. So in 7.5, we're introduced into vertex form of the equation of a quadratic. So instead of the standard form, which is ax squared plus bx plus c equals 0, equals y, I should say in this case, because we're dealing with functions, what we get in vertex form is y equals some value a, x minus h squared plus k, in which the vertex is given as hk. So one of the things we notice, one of the things you probably remember is that the value inside here, value h, you notice that there's a negative sign associated with it, which means that the value of the vertex will always be the opposite of what you see with the x, and the value for k remains unchanged. So if I have an equation like y equals, let's say, minus 2 times x minus 3 squared plus 2, I will have a vertex. Can you guys guess? 3, 2. To graph this, I will place the vertex. This case is going to be at 3, 2. So 1, 2, 3, and then up 2. And one of the things that we've been talking about and is this value of negative 2, which is the value of a. To understand what that 2 does is basically we've been likening it to slope. The bigger the number is, the steeper the sides of the parabola are. In this case, the 2 will tell us that if we go to the side, to the right or left of the vertex, one spot, that the next point that we can definitively draw, will be negative 2 down. So if I go to the right 1, and I'm going to go down 2. If I go to the left 1, I go down 2, and that sets me up with a more narrow parabola. Owen? Caleb. All right, that's my dog. With Caleb getting the dog. Anyway, this is how we'd graph it. Some other information that we can get from here is the axis of symmetry, which is the line that goes through the vertex. And in this case, it's going to be x equals the x value of the vertex, 3. And that's going to produce the vertical line going through the vertex. One other thing that we could be asked is whether this is a maximum or a minimum. Because the vertex is on the top, we call this a maximum. And the domain and range, two other things that we may be asked to do with the domain, it's almost always going to be, has always been the case, is going to be negative infinity to positive infinity. The range does vary from parabola to parabola depending on where the vertex is. In this particular case, the range will start at negative infinity and go all the way up to y value of 2. And because it includes the value of 2, I'm going to put a little bracket. A couple things that people have missed in the past is the axis of symmetry, remember, is going to have an x value, is going to be is an x equals. Some other people have lost points because of not recognizing that because we include the value 2, that it should be a box. In the range, we should use the boxy parentheses. Otherwise, I think that a lot of you were pretty good with this. So what I'll do is let me go to another page, and I'll put an equation down for you to graph, and we'll see if you can get the right answer. So moving on, 7.5. This is where we talked about vertex form and how to graph. A lot of you were pretty good. Here is our next graph. So this is for you to practice. And so I'm going to have a y equals 1/2 x plus 2 squared minus 5. So why don't you guys pause and see if you can't figure out how to graph that. Once you figure that out, once you see if you can't, or in the process, see if you can't find the vertex, the axis of symmetry, and the domain, and the range, and whether it is a maximum or a minimum. So I am going to pause for now, and when we come back, I'll solve this quickly for you. Okay, this is what I came up with. I have a vertex at -2, -5. My axis of symmetry is x equals -2. My domain, as usual, is -infinity to +infinity. And my range is going to start at -5 and include -5 and go all the way up to +infinity. In this case, we're looking at the vertex being on the bottom, and what we call that is a minimum. So that's the answer to that. There's other forms that you can see. For instance, this is also in vertex form. In this case, what's going on is that the vertex here is going to be 0, 2. So sometimes, again, if the value for the 0 coordinate, the 0 for h is if the value of h is 0, we just write it as x squared. So just something to be aware of, that you might see something like that. Okay, now we're going to go to the more recent material. And this is in quadratic functions, section 7.6. You did in 7.6. So in this section, we're going to be covering a few things. One is the ability for you to convert a quadratic in standard form to vertex form. This we do by completing the square, and is pretty challenging. Represents a pretty challenging part of the chapter. The other thing that we do in this section is we talk about how to use the formula h equals -b over 2a to be able to determine the vertex if the quadratic function is in standard form. So we can convert to vertex form, or we can also just keep it in standard form and be able to find the vertex in that way. What you need to do is be able to do both. So first thing I want to do is I just want to show you how we deal with the first part, the first thing that we learned. And we spent like one day doing this, and then we went the next day to number 2. So let me start with this first thing, is converting standard form to vertex. And we're going to be doing this by completing the square. So let me start with an equation in standard form. It's y equals 3x squared minus 6x plus 1. And this is probably the more challenging one that we're going to be doing, because any of these challenging equations mean that there's a value in front of the quadratic term, a coefficient that we need to deal with. So in this case, what we're going to do is factor out the 3. But before we do this, what we're going to do is take the constant and move it to the other side. So we're going to write it as y minus 1 equals 3x squared minus 6x. Now, instead of dividing everything by 3, as we did when we were solving, in this case, what's going to happen is we're going to factor out the 3. The difference is because now we're dealing with a y instead of a 0 like we did in the beginning of the chapter. So let's go ahead and factor out the 3. And we get 3. Inside we get x squared minus 2x plus something. And over here we have y minus 1 again plus whatever we add to the other side. So in this case we have a minus 2. We're going to divide it by 2 and then square it. Minus 2 divided by 2 is negative 1. Negative 1 squared is just a 1. But be careful here. We're not really adding a 1 to this side, because if we expand, if we distribute this 3, we would find that that 1 is actually a 3 in disguise. So we need to add the 3 to both, add 3 to the other side, and then we're okay. So now I get y plus 4. Now that I've completed the square, I can collapse that down to x minus 1, quantity squared, and bringing the 4 to the other side allows me to put this in, finish putting it in vertex form. Note now that we can see that the vertex is at 1, negative 4, and we have a pretty steep sides. You know, once you plot the vertex, you're going to use that 3 to tell you what's going to happen when you go to the left or to the right 1. And in this case, it's going to go up 3. So it's going to be a very steep and thin looking parabola. So you need one of these things to try yourself. And let me make sure, I just want to make sure that you do one that's got a coefficient in the front, so that you have to factor that out. So let's go with the following. So here's your practice. Take out your piece of paper, your notebook, and I'm going to go f of x equals 4x squared plus 4x minus 5. So you're going to want to pause the screen right now so that you can copy down this problem. One of the things that I didn't do in the example is I started right off with y. So I'm going to remind you that we can change that f of x for purposes of simplicity to a y and write that as 4x squared plus 4x minus 5. So look at the sample that I drew, that I wrote. If you have any questions about how to solve this, if you can solve it all on your own, that's awesome. And in a moment, I will, after you pause and turn this back on, you'll be able to see the answer. That's everything. Just with a couple of these. 7.6, this is all the new stuff that you haven't done on a test yet. The trickier parts would be converting standard to vertex form, and we have the equation. We have that equation below that represents that. Remember that there's several important steps here. One is getting the constant on the left hand side, and then factoring out the coefficient of the quadratic, and et cetera, et cetera. There are many ways for me to give you a problem like that that's really difficult. I don't plan to give you one that's really difficult. I just want you to demonstrate the skill. In 7.5, we're introduced to... Let me see how big that... Whoa. We're introduced to... Oops, stop moving you. So let's see how you did. I whipped through this. Ooh, it looks like I've got an error right here. Let me fix this really quickly. Anyway, starting off here at the beginning, set it, change the function notation into a y. Second step is, I factored out the 4 at the same time that I added the 5 to both sides. And having the middle term gives me 1/2, and then squaring it gives me the 1/4. And be careful now, what do we add to the other side? Remember that we're distributing the 4. So the 4 times the 1/4 means that in reality, on the right-hand side, we really have just a 1. So that's next step. I'm going to collapse the perfect square on the side on that second line, and I rewrite it as x plus 1/2 squared with the 4 on the outside. Over here I have the number 5 plus 1 is 6, and then I subtract the 6 from both sides. Now I have the equation. Of course, now we can get the vertex as being it's going to be negative 1/2, negative 6. So the next thing we're going to move to in this chapter, the part 2, is how do we graph a function that's in standard form without converting it to vertex form. You need both skills, and the reason why is because later on in pre-calculus you're going to be completing the square and changing a lot of the formulas for other types of curves like hyperbolas and ellipses, and you'll need to be able to complete the square to do that. So this skill that we just learned is something that's going to be important later on. But there's also a way to graph a function without going through this, and without converting it into vertex form. And that relies on the formula that we have for the x value of the vertex, which says that if you have an equation in standard form and you take negative b over 2a, you will be able to determine the x value of the vertex. So what we're going to do is we're going to use this technique to find and graph a line that's in standard form. And we'll do that on our next page here. And where we convert it to vertex form, and you'll note right now that the x value of the vertex was negative 1/2. So it's definitely confirming what we should expect on this side. So we have two systems to do the same thing. And then the last piece. Okay, so here was our sample. Let's see how we can apply that. So let me write down the equation that we used just a moment ago and put it into vertex form. So the idea is to find the vertex of the following. The vertex, I'm going to go ahead and use h of x equals 4x squared plus 4x minus 5. We already know what the vertex is for this, but let's go ahead and use the formula. First off, I have h is going to be equal to negative b over 2a, which is negative 4 over 2 times a, which is 4. 4 is reduced. I end up with h equals negative 1/2. Now what I do is plug in the negative 1/2 into x to get the k value. So k is going to be equal to 4 times negative 1/2 squared plus 4 times negative 1/2 minus 5. So it looks nastier than it really is. What this is going to be equal to is 4 times 1/4 plus, well, 2 goes into the 4 2 times and into the 1, so we get minus 2. Minus 2 for here, and then the minus 5. 1/4 of 4 is equal to 1 minus 2 minus 5, which should be equal to minus 6. And if we look back, here we are. Let me just go ahead and run through what we have here. So first step, and I feel like I want to erase this and start all over for you guys so you can see that. So let's go ahead and first step, I'm going to take the h value, and that's going to be equal to negative b over 2a. So let's go ahead and plug that in. I'm going to get negative 4 over 2 times a, which is 4. The 4's will cancel, and it's going to leave me with a negative 1/2. I don't know if you noticed, but this is the exact same equation that I used in the previous page. So let's go ahead and finish. How do I get the k value, or the y value of the vertex? We're going to do that simply by plugging in the negative 1/2. So I'm going to write 4 times negative 1/2 squared, and from there I'm going to add 4 times the negative 1/2 minus the 5. So basically I just plugged in the values on the top with plugging in the negative 1/2 into the equation on the top. So now what I have is 4 times 1/4, negative 1/2 times negative 1/2, plus, actually not really plus, it's going to be minus 4 times negative 1/2. The 2 goes into the 4 2 times, but there's a negative sign, so it's minus 2, minus 6. So keep going here. We got 1 minus 2 minus, minus 5. Guys, it's getting late. Sorry about this. Minus 5, which gives us a total of negative 6. So now we have the vertex negative 1/2, negative 6, which is exactly what. Now, I know that you guys think that's pretty redundant, but we can live with that. The question is, how would I graph this? I think I need a little bit more space. Let me go ahead and take this over here, and let's go ahead and graph it. So I'm going to have to shorten this a little bit. Let me go, every 2 is going to be a 6 for me here, I think. So 1, 2, 3, 4, 5, 6. That's my negative 6. And actually I want to go negative 1/2 first. So negative 1/2, negative 6 is somewhere down here. And because I have a 4 for my a value, that's if you look up here to the upper right, do you see this 4? That is the value of a. That means that I go over 1. If I go over 1 and I go up 4, that's where my definitive points are going to be. Now, unfortunately, this graph paper is really pretty fine, so it's kind of hard to know to see all this, but in general, this is what we're going to be looking at, is a graph that's relatively steep. It's got a vertex at negative 1/2, negative 6. And when I go over 1 unit, it goes up 4. So a couple other things that we might be able to do is find its axis of symmetry. the axis of symmetry is going to be x equals, what do you think? X equals -2. We know that it's a minimum. And the one last thing that we need to be able to do is to find the zeros. And what I'll do is, let's go ahead and do that on the other side. Actually, what else? I think I can do it right in here. Let me go ahead and find the zeros. To find the zeros, what we're going to need to do is just to set the y equal to 0. So instead of having h of x equals 4x squared, we're going to have 0 equals 4x squared plus 4x minus 5. And likely the easiest way for us to find out what the zeros are is going to be the quadratic formula. This doesn't simplify. This is not something that we can factor, and we could complete the square on it, but this is also one of those ones that you have to divide by 4. So let's go ahead and get some practice with the quadratic formula. So in this case, x is going to be equal to -b, or -4, plus or minus square root of b squared, which is going to be that 4 squared, minus 4 times 4 times -5. Now let's be careful here. We got a negative, and we have a negative here. That's going to make this whole thing a positive. This whole thing is over 2 times a, which is going to be 2 times 4, which is eventually going to be 8. So keep going. -4 plus or minus the square root of 16 minus. Now let's see if we can do this one. 4 times 4 times 5 might be tricky, but let's go 4 times 5. And that's going to be our 20. And then 20 times 4 should give us 80. But there's 2 minus signs, so I know that this is going to be a positive 80. Again, all over 2 times 4, which is 8. Let's simplify a little bit further. We see that in the square root, we should be getting a 96. And can we simplify the 96? Likely so. Let's go ahead and do it by prime factoring. Get 48 times 2, 2 times 24, and 8 times 3, and 2 times 2 times 4, and then 2 times 2. So got 2 2's here, 2 2's here, and a lonely 2 and a lonely 3. So that means that we can always take out pairs. 2 2's come out as 1 2, and anything all by itself just stays all by itself. So we get this is equal to 2 times 2 square root of 2 times 3, which is 6, or 4 root 6. All right, I promise I'm not going to give you something that's this difficult to simplify, but let's go ahead and just finish this up now. So I've got -4 plus or minus 4 root 6 over 8. And one mistake that a lot of people make is you forget that there's 2 terms on the top that have to be reduced. So if I'm going to reduce everything by 4, which it looks like I can, I divide everything by 4. I'm going to get -1 plus or minus square root of 6 all over 2. And we can leave the answer like that as far as I'm concerned for the test. But these are the zeros. So there's a 0 at -1 plus root 6 over 2 and -1 minus root 6 over 2. I will likely take a kinder approach to this, and I'll give you an example of that right now in the next page. So the last piece is how can we graph over here? Instead of converting the vertex form, we can use -b over 2a to find the x value of the vertex, and then we plug that value in to find the y value. We can now graph it. The one thing that I'm adding on here is this idea of finding the zeros. the problem I chose for, the problem I did was pretty nasty, and then the problem I chose is, here's a problem that you can do using that same technique. Okay, this next one for you to practice on is going to be written as f of x equals negative x squared minus 2x plus 8. So what I need to ask you to do is to find the vertex, the domain, the range, the axis of symmetry, and the zeros. Now, unlike the one that I just did, the zeros here actually come out to nice rational numbers. So if you don't get nice even numbers, then something must have gone wrong. But let's go ahead and give this one a shot. So again, you're going to use, in this case, you're going to use the formula for h equaling negative b over 2a. I'll start you off. This is going to allow you to find the vertex. It's going to allow you to graph it. So make sure you try to graph this. And from there, you can find the domain and range as the axis of symmetry. And then you'll need to solve the equation by setting f of x equal to 0 and see if you can do that. So I'm going to pause right now and have you guys see if you can't finish this one up. And when you turn it back on, I'll have the solution for you. Okay, let's see how you did. You see my calculation for h is -1. If that doesn't match yours, why don't you just pause for a second and look at my calculation. My value for the y coordinate, the y value of the vertex is 9. I can graph this now. So I'm going to go to the vertex -1, +9. I'll make my graph so it fits that pretty well. 1, 2, 3, 4, 5, 6, 7, 8, 9. And in this case, I've got an a value. A is -1, and that tells me again what's gonna happen when I go to the right or left 1 unit. If I go to the right 1 unit, I'm going to go down 1. Go to left 1 unit, I go down 1. So this is a parabola that faces downwards. Therefore, we have a maximum. What other things do we have? We have a domain of -infinity to +infinity. Surprise, surprise. Range is going to be from the lowest is -infinity to the highest, which in this case is going to be 9. Box it, please. Axis of symmetry, x equals -1. The zeros. Well, let's go ahead and let's do this one. This actually factors. So if we set this, what I'm going to do is change f of x to 0, and that equals -x squared minus 2x plus 8. Now that it's set equal to 0, I can multiply everything by -1, and I can rewrite this as x squared plus 2x minus 8. And there just happens to be 2 values that I can factor here. It's going to be x plus 4 times x minus 2 equals 0. And so my 2 zeros are at -4 and +2. That's where my x values are. So that means that somewhere over here at x equals 2, it goes through here. And then at x equals -4, 1, 2, 3, 4, the parabola goes through here too. There we go. So that's the idea. Those are my zeros. So zeros are -4 and +2. Wiggle, 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 wiggle there. So yeah, adding the zeros on as a question does put a little bit more work into it, but definitely doable. So expect one like this. I will be forgiving, though. I'll try to make sure that that your zeros come from a quadratic that's factorable. So that'd be one less thing for you to worry about. That doesn't mean you can't put it in the quadratic formula, but if you factor it, it should be a lot easier. Okay, so in summary, let's take a look at the beginning. The problem I chose for you was a lot more forgiving. As you can see, the zeros actually ended up becoming integer values, and I'll likely do that's probably what I'll be doing for you on the test to make sure that the numbers come out nice and even. One last thing that I didn't talk about is that you're likely going to see one word problem. I don't know exactly how to. I mean, there's so many. There's quite a variety of different word problems that can be chosen from. We've seen quite a number of them, but what I would recommend you do is to look at some of the problems on page on page 314. And what I'll do is I'll include in my recommended questions to do some of the ones, and it's probably going to be the same that I gave you for the quiz, but on page, those of you that still have a book somewhere, on page 314, there's several word problems that would be, I think, definitely game, and I'm looking at questions 1 through 6. What I'll do is include these questions on my list of problems that you should try, and hopefully you'll come up with at least a good start, or maybe a good guess on this thing. I'm not expecting everyone to get it right, but I do expect everyone to put in a good deal of effort, and from that I'll try to make sure that I give some points in lieu of that. So don't forget word problems. And you'll only get, there's only, as I need to make this test pretty short, it's a 15-minute period. I'm going to try to make the test such that it will fit within the period, even for those that have the extended time. So I'm clearly going to have to choose only one question per section for the most part, and not double up like I did for the quiz. So with that, I turn you to go back to my essay and open the PDF file that I have there for you, and see if you can't do a little practice for the test on Thursday. Take care and have a great day all.
Happen.